这是一个类基因演算法模型。首先，该模型建立了一个有边界的生物族群系统，每单位时间产出定量的食物，并创造大量的标准单一种生物个体。对于每个个体存在3个遗传因子：速度、大小及感官。而在该系统内，评断个体的好坏是由该生物体在单位时间内所吃得的食物而决定。当吃到1个以上的食物时，该个体能存活到下一单位时间，而吃到2单位以上食物，除了能存活以外，亦能依照自身遗传因子繁殖一个与母体类似的个体。经过长时间的演化，族群的个体总数、平均速度、平均大小、平均感官皆能达成平衡，而这平衡与初始给定的个体数量、食物密度等参数相关。借由上述模型可得知，基因演算法可经多次复杂的运算后得出在给定条件下的最佳解。事实上，熟悉深度神经网络学习的同学可能可以看出，其实基因演算法是一种将梯度下降改为随机演化的机器学习，而此由配子交配的灵感来自人类对生物遗传学的研究结果，是一个经典的仿生科技应用。
Finally, I'll introduce how to apply our genetic algorithm. When we need to solve a certain problem, we can first parameterize the factors that affect its consequences. Parameterizations allow us to analyze and adjust our individual more systematically. We will then build a group based on those variables. All individuals in the group will be considered possible solutions to the problem we are trying to solve. We will base on how well these individuals perform to the desired goal under our constraints to establish a set of scoring standards, in which we will give greater advantages of passing genes to the next generation to individuals whose performance can better meet our expectations. Through this kind of process, after continuous evolution, the group will appear the best solution to the problem we seek. The algorithm doesn't need to focus on the gradient changes of the objective function, but instead evaluate the evolution of individual genes in the entire population and observes the final evolution results to get the best solution. Because the genetic algorithm observes the evolution performance of the entire group instead of analyzing the evolution performance of each individual one by one, and some perturbations are also added in the system in each generation to make the group's genes more diverse. So in this way, we can find the global optimum instead of the local optimum. Because the genetic algorithm doesn't need to analyze the gradient and other data, we can use it to analyze these continuous functions. For some complex problems that we may not be able to solve, we can also refer some of the results obtained by the genetic algorithm as a reference. The example here is about how genetic algorithms are used to design antennas. There are many frequency bands for electromagnetic waves, and the shape of the antenna may also affect its receiving effectiveness on electromagnetic waves in specific frequency bands. So if you want to design an antenna which can enhance the reception effect of a specific frequency band, we can use genetic algorithms. We first parameterize its shapes and add some variation in a semi-random way, and then continuously score the performance of each individual to save those factors that can make the antenna perform better. After several generations of evolution, we will get this complicated shaping antenna in this picture, and it's the best optimum of the antenna with the best reception effect in the X-ray band. Compared with traditional algorithms, genetic algorithms can be used to analyze very complex objective functions and limit the types and ranges of variables. Due to its advantages, genetic algorithms can be used in many places, such as scheduling problems or some complicating projects, such as stock market forecast or designing antennas like the example. That's the end of our presentation. Thank you for listening.